So next up, we have three of my favorite people, Clayton, Derek, and Mike, who are going to come and tell us everything we need to know about OpenShift 4.0. So come on up and unplug my laptop. That'll take a minute or two, and we'll do this. And so the way that this, while they're doing all the shuffling here, the way that today works is there won't be a lot of time for Q&A unless someone really does a short demo, which I doubt that's going to happen now. At the end of today, we're going to have an AMA session that Joe Fernandez is going to moderate, and there's speaker questions there. So at the very end of the day, this is going to keep you here till the end of the day. We'll make all of these guys come back on, plus some of the other engineers that are in the room, plus some of the product managers, and you'll be able to ask them anything. So start thinking about what those questions are and what you will do, and keep an open mind, because there are going to be a whole lot of presentations through the whole day, and people are going to be talking about doing things with OpenShift that you haven't even thought about yet. So please welcome, and here we go. And I'm going to get off the stage and let you guys rock and roll.
Great. Is this thing on?
Oh, wow. So I'm sitting in Jim's seat.
Oh,
I feel
yes.
smarter already.
Nice, nice.
So if I can get that casual look.
Jim Whitehurst at Commons, unbelievable. And to prove that everybody's a commoner at Commons, we only give him 20 minutes. That's so Clayton could talk for 3 hours.
Yeah, well, that's true. And it's actually funny because Jim just stabbed us in the back when he was up there, because what we have been trying to build is something that is easy to use and works well together and lets you not worry about details. But Jim told us that you guys want a box of Legos. And so we're going to take this away. We're canceling OpenShift 4. We're going to go back to OpenShift 3, and we're just going to do that for a while.
So this is a product manager's dream, right? We have a steering committee, members from upstream Kubernetes. There's SIG chairs. There's lead architects. I could just go home, and these guys could take care of the rest of the session. But we sat down in the next slide, and we thought about what could we tell you that you're not going to hear this week. And this is probably the best summit for OpenShift that we've ever had, and that's hard to say every year. It gets bigger and bigger. But you're going to hear unbelievable success stories from just about every industry out there. And what could we top? What could we say? And what we came up with was the inside scoop, right? We're going to tell some stories about some of the things that were hard to solve. And we cut it down to 4 things that were hard to solve in OpenShift 4. And we're going to tell you, pull back the curtain and tell you some of the miseries. So let's start from the beginning. Let's start with install and upgrade. Now, when we looked at installation and upgrades, you would think that all the problems were in the install and the upgrade. But 70% of them came from other parts of the product, right? Because when you're upgrading, you notice some weird thing in the kubelet went wrong, or some weird thing in the storage went wrong, or some weird thing in the operating system went wrong. So how did you guys attack that? How did you approach solving that problem where 200 different things could have been the problem?
Oh, we were supposed to solve that?
Yes.
We wrote a lot of operators, and Mike works this hard. I'm trying to write one now, and maybe we'll see a little demo later. But I think our first point was we want to make sure that every cluster a customer installs has success on that first cluster install. So
yeah, and the first cluster is kind of the important one, right? So you're trying something out, you want to see what it looks like, you're doing testing. Whatever it is, that first cluster is actually the one that matters the most.
So in our prior release, a lot of people first touched OpenShift by reading our reference architecture documents. And so we kind of thought there was a friction to actually using and experiencing the product that we wanted to eliminate in our 4 series now. And so we were looking to make sure that we could get more of a turnkey cloud-like experience on those environments where it could be supported.
Yeah. And like a reference architecture is a great example of something where we take somebody who really knows the problem, and they know what customers are doing. They know, I need to run secure this way, and I need to do this in order to meet this. Or they know the platform that they're installing on top of. And we said, well, instead of giving you a reference architecture, why don't we just bake that in and ship the reference architecture? Makes sense.
Yep. So to show this off, we've kind of tried to do, I guess, our reference architecture as code, as Clayton mentioned. So how many people in the room took part in our early beta, just to gauge some hands?
Nice.
Okay.
Or tried the dev preview.
So some of the folks in the room, this might be a refresher course for them. But if you were in the beta, you'll see that we had a new install experience. And if you went to our try.openshift.com site, you eventually found yourself to a page here that led you to our developer preview. and gave you some basic instructions on how to deploy a cluster. And so I'll show that now. So the first thing you have to do is actually get an image pool secret to get you access to the actual bits that you'll deploy. And then, hopefully people can see this in the back, you had to download an installer. And so we have a new installer. It's called OpenShift install. It's pretty simple to use. And so I'll do that here. And in one command, you can get presented with an interactive wizard to guide you through your install and ask you for an SSH key, pick your cloud, your domain, and I will call this Carr.
So while Derek's doing this, I have a question. How many people were at KubeCon this year in Seattle? And how many people saw the demo that we did then? OK, that's a good number. Not much has changed because, again, the experience is about trying to take most of those choices and boil them down to what matters. And so in this opinionated reference architecture, which is something we'll get into a little bit more, we're just trying to focus on the choices that actually matter for standing up a cluster. And once you've installed it, if it works that time, then we want it to be possible for you to change and to react to the changes that you need to do as the cluster evolves over time.
Yep. So you saw I answered about 5 questions, and the wizard is going to give me a default cluster with, in a particular cloud, an HA setup, everything spread across zones as expected, and you have a default set of workers. And in the interest of time, I guess we'll move on to, like, once your cluster is up, our next problem, Mike, was trying to figure out how to maintain that cluster reliably. And let's talk about what we hit with that.
Yeah, and reliability is really important. So you'll hear us talk this week a lot about operators. When we acquired CoreOS last year, a lot of smart folks on the CoreOS team had been taking the lessons that Kubernetes had, the patterns and the possibilities that are available in Kubernetes. You know, it's infrastructure for running applications. Well, I think that's the unique thing about what we're trying to do in the Kubernetes community is that it's the first opportunity we really have to have an application-focused infrastructure. It's incredibly flexible, can talk to infrastructure, can abstract these things, can give you HA out of the box, lets you manage rolling deployments. And so, you know, the next question is, well, if we're building this platform that's so great at running software, why don't we actually use that platform to run the software that runs the higher level services?
Yeah. So what you see here is our console in the 4X experience. And you know, traditionally, people would install a Kubernetes cluster, put some monitoring on it, and then hope it stays up and hope that your monitoring solution tells you when something went wrong. And so we wanted to level that up a little bit. And Kubernetes is a very big surface area, especially when you want to add the necessary components to actually make it a useful product in production. So what you see here is our out-of-the-box cluster status page. I'm an engineer, so I'm running our nightly build. If it goes wrong, we'll fix it before we ship. But right now, everything's green, and life is looking good. And so one of the new things you'll see here is, in our cluster settings page, the list of cluster operators. So when I talk about Kubernetes as a big system, you have the core assets that come out of the Kubernetes project, and then you have a series of add-ons that you typically need to life cycle with those core assets. So you need DNS, you need a network. Typically, you want monitoring.
You want authentication, you want ingress. And actually, what we've seen over the last 5 years since we've been involved in Kubernetes is that Mike never stops saying, well, just one more thing. We just get one more thing. And every time we had one of those one more things, it was it's an upstream project. It's innovation. It's people coming up. But we have to productize it. We have to think about security. We have to make sure that it's reliable. We have to test it. And each one of those steps is about, OK, well, let's take this bit of technology, run it on Kubernetes, make sure that we can keep it up to date and keep it secure. And over time, maybe it's replaced by something new and shiny. We have to be able to pull that out. And so the operator pattern, in a lot of respects, is just a fancy way of saying, we want to boil all of that information about how to run the software into the platform when we ship it, just like the reference architecture. The installer is the reference architecture materialized, and these operators are domain-specific knowledge about how to run ingress on Kubernetes.
Yeah, so just to touch on this a little bit more, each of our operators that are running on the platform, managing the platform, as an admin, you can come in and, aside from the monitoring view, get a view of everything that's in the cluster. if things going well, what version it's at, if there are any problems. And this is really only useful if it does something for you in response to a bad thing happening. Like, does it rotate your certs? Does it recover a cluster when someone makes an admin error? And so let's have some fun, Clayton. I'm going to try to delete our network.
I don't know, this is a good idea on stage. This is terrible. I can't look.
So I think it's a daemon set. And make sure.
We have a lot of daemon sets.
We do. All right, I'm going to delete this daemon set. Hopefully our cluster doesn't die.
Derek, you deleted the wrong one.
Oh, shoot, that was DNS. That's not good. So let's see if our operators fix this. So typically, an admin is working late at night, trying to figure out what's going wrong with the cluster. And now they would have been getting paged. So the DNS service is reporting it's degraded. I'm getting woken up in the middle of the night. Oh, what happened? It looks like our operator kept our cluster alive. My web UI is still running. Problem averted. Everything's good.
We didn't try that like 50 or 60 times to make sure that actually worked. We promise. But this is the idea, right? Is all of this is config. It's Kubernetes applications. It kind of leads into the question of, well, you have an operator and you need to make sure it's there. Who guards the guards, right? Who watches the watchmen?
Yeah. So, we had this journey where we go and tell all of our teams, hey, you're the experts in the Kube API server. You're the experts in kubelets. You're the expert in networking. And we challenge each of those teams to go and write an operator, take their knowledge, and say, you know how best to operate your software. But as Clayton said, you need something to roll that all together, to like bring the cluster as an atomic whole, and know that when we're shipping all these operators in one package, that we at Red Hat have certified and tested and made you sure that you can trust them as a unit. So what we have new in the 4.0 view here, if I go to the next view.
And let's just double click on that for a minute. There's this platform, the 4 series, took probably 16 months of development and R&D. Why was it so difficult for the operator aspect of it, to get all the Scrum teams, all the engineers to buckle down and write their operator?
Are we being recorded? So the honest story is that Kubernetes is still new, right? So we've been doing operations and IT management for a very long time. The automation that we use keeps improving. So it used to be a long time ago, we didn't have configuration management. And then we added these tools that said, well, we can do this thing over and over for you. As long as you write it down once, we can come back in. And there's all sorts of wrinkles in that, right? You drill down and you say, well, maybe somebody got onto the server and changed something. And so this time, the configuration management script doesn't actually work. So you go fix that bug and you move on. And we've built these better and better and better abstractions. We know what works, what doesn't. A lot of what is applied here is taking those lessons from operations over the last 30, 40 years at scale and boiling them down to their essence. And it's still hard, right? You still have to write some code. That code has to be tested. Now, I will say that the beauty, and this is why I think Kubernetes has succeeded more so than efforts, is because in Kubernetes, you have this idea that these things run all the time. They're continuously. It's a config loop, but it's a config loop that runs every second. So if you mess it up, it happens right away. So that makes it easier to test, makes it easier to validate. That config's not much more complex than the config that we've been doing for 10 or 15 years, but we're doing it all the time, and so that shows up fast. So it's like backups. This is like one of my favorite sayings, which is if you've never tested your restore, you don't have a backup system, you just have a very expensive tape array, right? And that is what we've tried to do with operators. And getting teams to be able to have that code, it was a mind shift, but it was also something that they were ready to do, and I think a lot of people in the community are ready to do that as well.
Yeah. So as you saw, there are about 25 out-of-the-box operators managing key aspects of the platform here. And we needed a top-level operator to ensure all those 25 children in the product are working as intended. And so we have a concept of a cluster version operator. It's the watcher of all the watchmen, and it's running on your cluster as the root thing. And as Clayton said, it's just doing a constant config loop check to say, is the desired state of the cluster as I need it? Are all my operators at the version they're expected to be? If I had gone and deleted my DNS operator, that operator would have been restored within, 5 minutes or so? So it's a pretty quick, constant iteration loop to make sure, is your cluster as it's intended? An admin didn't make a late night error trying to restore this thing.
And I'll add here too, like, this was an idea that the CoreOS teams on Tectonic had been working with for a while, and it's kind of how do we build the simplest possible thing that could actually work? And the config loop, the dumb config loop of go in, update, and make sure that something's there, works really well with operators when you have a top-level operator talking to lower-level operators, because you have a really simple problem, make sure every operator is up to date, and then each of those operators says, okay, make sure that my application is up to date. So we have evolved and refined a pattern that's actually been working pretty well for a couple of years now.
So another thing that came out of the CoreOS team when they joined Red Hat is this concept of figuring out I'm at a particular version and what are my safe versions to upgrade to. So this top level operator we call the cluster version operator. It can be pointed to an upgrade service. And so you'll see on the cluster settings page, I can see that I was running nightly. This is a cluster I installed from a 2-day ago build. It's currently running our May 4th build. Since, as I said earlier, I'm an engineer, I can subscribe to different channels for which I want to get updates. And so as an admin, I can pick a channel if I want to go on my stable channel, my pre-release channel, and I was on our nightly channel. Yeah,
and we'll have more info about this. Like, we want to make pre-release and nightly releases easier to test, right? Because I think this is a really important discussion that we've had with, it's not enough for the software to work when we test it. It needs to work when people install it. And Kubernetes has always kind of had an evolving and quick-paced nature. We want to make it easier for people to react to the new software as it comes out. And so you'll see more in the coming months about the nightly channel and the pre-release channel, where updates are available before we're ready to say, this is to recommend them as the installed version. It gives you a chance to test these out early, to build your own automation around testing and deploying updates, as well as to just get some comfort about what's coming. You may not be ready to update, and Red Hat's really good at delivering production updates to systems for a very long time. That sort of flexibility is something that we want to offer to customers so that you can be part of our testing process as well, and we can take feedback as the software is available.
So it's a little anxiety-inducing to upgrade a Kubernetes cluster live in front of 1,000 people. So hopefully this works. But the experience is pretty simple. An admin can come in. There's a command line to do the same thing. I can see that there's new versions of the software available. I will check and pull our May 5th nightly. And Clayton, you forgot to sign the NDA.
Sorry about that. Yeah, so
go ahead.
Signing, Red Hat software, we take very seriously, the software supply chain, and supply chain attacks are on the rise. And at Red Hat, like, a key part of our DNA is how do we release software to the world and trust it? And so what you're seeing Derek doing here is something that you should never do, ever, anyone, which is basically there's a built-in check that says, is this content signed by the appropriate party? And so Derek is overriding that and completely voiding his warranty, and we won't hold him accountable for that.
Yeah, so this is our nightly engineering build. And so while Clayton's picking on me, I'll give Clayton a round of applause, because I know he spent a long time getting that progress bar to work. So what's happening right now is the cluster version operator says, oh, there's a new release image that I want to roll out across my cluster. The operator is going to pull down that image from our registry, and then from that know the set of manifests to apply to the cluster to drive the upgrade. And so in the interest of time, we'll let this upgrade proceed, but as you would want to watch it happen, once it finishes downloading the release image, you'll see each of these individual operators start to report that they're upgrading, and their version will change to the new version. And so we're hoping that this provides an easy one-click upgrade trusted experience. So.
Nice. Very, very sweet. You could click an update button and walk away, no matter what the cluster is doing.
Yes. Maybe after the first couple times.
Maybe the first couple times. So, skipping ahead, we should probably move on from operators. Let's talk about something that probably not a lot of people knew was even being engineered or touched. So, when you all out there use the OpenShift beta, part of that beta was a lot of code work that these engineering teams did on getting their CI/CD processes down, sort of revamping, re-energizing them, but also building a back-end service that would allow this upgrade technology to really work. Can you talk a little bit about that?
Derek, can you go to the release page? Can you pull that up?
I don't know if I can do it right now.
I'm gonna scare Derek. He doesn't like going off script. So a big part of the evolution of software, and this is something that I think everybody here knows, is that as we deploy more and more complex systems, testing those in the real world, doing that repeatedly, tying those into our software delivery processes through code automation, through test automation. And on the OpenShift team has actually been a very serious, we've made a very serious investment on not just testing everything and building these clusters all the time, but running the OpenShift infrastructure to test itself on OpenShift. And so that's actually given us a lot of confidence as we've gone forward to make sure that if we want to be able to build and deploy software, we should do it the same way that anybody else might build and deploy software as well. Because OpenShift is just a bunch of container images. And allegedly, I've heard, OpenShift is a pretty decent place to run container images and to build them. And so we spent a lot of time building out infrastructure that ensured we launch, build, and build our images. I think we build something like 4,000 or 5,000 images a day on top of an OpenShift cluster. That's only if everybody's working. Obviously, on weekends, we only get half that. We spin a lot of clusters every day, and the numbers can vary. I think as we're kind of trending down from the end of our release, I think we launched something like 5,000 clusters this week as part of the CI automation. And we've actually gotten some nasty grams from one of our cloud providers that we're heavily exceeding their rate limits in ways that they did not anticipate that we would. And actually, that's been really helpful for us because we forced all of the developers on the OpenShift team to have to develop in a shared cloud account where we were regularly exceeding rate limits. And that was actually a great example of, well, you're hitting a rate limit. We're not going to test less. We're going to force you to go make the software more parsimonious about how it uses the cloud. And so that's sort of using what we build and using the software that we expect you to build on helped us find and encounter those scenarios earlier.
Yeah, so Mike's going a little off script and he's throwing me off, but to drive this point home, let's talk about what the OpenShift development organization has been doing. So, this cluster's up, and as Clayton said, we run thousands and thousands of tests and simulated upgrades every day, all the time, on every PR, basically. And, in a pristine testing environment, you might get a false signal around the actual health of those clusters in customer environments. And so one of the things we've been trying to do is get some telemetry data optionally sent back to Red Hat so we can understand the information that we need to better debug a customer environment without having to go and directly ask, like, how big is your etcd? How big is your cluster? What are your problems that you're having? And so one of the things, if you opt into that telemetry setup, is you can take your cluster ID, and I will copy that. And here, this is cloud.redhat.com, and hopefully it loads. And when I log in with my Red Hat account, I have a new thing here that lets me see my Red Hat OpenShift Cluster Manager. And I'm currently associated with the OpenShift development organization. So as Clayton said, we spin up a lot of clusters. And based on the state of those clusters being up and down, there's about 900 right now. So let's find the one I created right here. And this is our live Commons presentation cluster. And so, I can get an aggregate view of all the clusters associated with my organization, if they're healthy, unhealthy, what their size are, and perform some actions on them. And so, remotely, we can know that if a customer or a user is being successful with a particular upgrade version we roll out, and we see that there's problems happening, then we at Red Hat can be more responsive in saying, hold on, we might not want to.
Yeah, and I talked about pre-release and nightly channels, getting an early signal from customers and users, people who are evaluating OpenShift, people who are hobbyists. It's actually really important for us because Kubernetes has kind of been a very big and open community, and there's a lot of great CI work that goes into testing the core. But for us, it was about, well, how do we test everything as a unit? And when we apply an upgrade, Derek talked about, well, are you sure that you really want to push that update button? We want to be really sure. And so we have a number of patterns and tools and services that we're trying to make that both customers and partners and developers can make use of to become part of that early testing fleet. That gives us data that allows us to say, okay, well, before we start suggesting updates to production servers, maybe we should make sure that all the development clusters upgraded successfully. And this kind of relationship between Red Hat and our customers is very important to us. Obviously, we want to earn and deserve your trust. And so it's very important that we go through this in a very deliberate way. But expanding on the ideas of Red Hat Insights and looking at how we can make sure that the software that we give to you is working as we intended. Our support relationship with you really is that important to us that we can find, identify, and understand issues before they become production issues.
So there's two things happening here, right? There's a SaaS almost relationship that helps the upgrade become more intelligent. But there's also a portal that you just snuck in here. It's beautiful, by the way. And it's showing me all my OpenShift clusters all over the world, like the ones I have on dedicated, the ones I have on Azure, the ones I have anywhere.
Yep.
They're all right here for me.
Yeah, and again, I think this really gets to the heart of software. Software is changing. We want to make sure that we change with software, and Jim alluded to this, is the idea that software is this package bundle that you take and run in this very disconnected environment. That model isn't completely broken, right? There's still reasons that you run disconnected, that you run in air-gapped environments. But I also think that the rate of change in software is increasing to the point where the software becomes more complex, security becomes ever more important. It's not enough anymore to just rely on static network defenses or to ensure that a system isn't changed. We need to be able to change with the software. When critical security updates in fundamental aspects of every bit of software we run are coming out at the rate of multiple times a year, those systems need to be updated. And that's something that Red Hat has a long experience with. If you trust us to run the update, you need to be able to, we need to be able to earn that trust to be able to click that update button. The idea of bridging the gap between a managed service and this thing that you just install once for the software that you're running is increasingly important to be able to react to the challenges we face.
And for the disconnected, the people who can't use a portal, you're building this off of stock parts that we're almost dog fooding first and then moving into the on-premise. What are we using in the back end?
So this is a very simple system. We call it Cincinnati because Mike's from Cincinnati. And we like to say that Mike is kind of the one who drags us in a particular direction. And so Cincinnati offers suggestions about what versions to upgrade to. And those suggestions are based on the best knowledge that we have. But that is something that's a very simple service that could be run in an offline environment in the future.
And there's Prometheus, this massive Prometheus cluster that we're housing.
Yeah, Red Hat's made a huge investment in Prometheus. And so in the upstream community, there's actually a lot of new work going on around a project called Thanos. I'm not going to spoil the Avengers movie for anybody here who hasn't seen it. And so that idea of using our own products to offer something that could also be run on premise is part of Red Hat's DNA. And so this idea of how do we make sure that you have the information available in a cluster, but if you choose to, how does that information flow back? A lot of those natural channels are technologies that we've already invested in heavily.
Cool.
Yeah, so there's some other things Mike's went off script, but I'm going to pull him back on script.
You thought we were going to stick to a script.
When we were talking about challenges on really wanting to ensure that upgrades are successful, that customers are able to keep up with Kubernetes as Kubernetes evolves, one of the things that Clayton and I have lost a lot of sleep over is Kubernetes is a really big system. I did this exercise before I got here and just tried to ask how many flags do the 4 basic components of Kube have. And I don't know if anyone wants to throw out a number, but I think you all might be off. But it's 600 customization points just in those 4 areas.
And that doesn't include the rest of the things that you need to make a Kubernetes.
So that doesn't include DNS, that doesn't include networking, that doesn't include monitoring. And so we thought about what can we do to make the 4X experience better is we kind of had this tension within the development organization on the difference between product configuration versus project configuration. And so one of the things that you'll see new in 4 is this view on global configuration. And what you're actually doing here is you're just driving Kubernetes resources that we've installed as custom resource definitions. And you can configure a safe set of flags that our engineering team has vetted and said will work together as a unit.
And to drill into this a little bit more, I mean, this is the operator pattern, right? The idea that we have these things on the cluster that can react to configuration. You want them to be driven by a config loop. These API objects are just like any other Kubernetes API object. If you want to store them in a Git repo and then periodically apply them, it'll work just as well. That idea of being able to change the configuration of the cluster after the fact was actually surprisingly difficult for a lot of the engineers on the team. They were like, what, I can't just add a new flag to Ansible at the beginning of the install? We only have 2,400 flags. What's another one? Yeah. And we actually had a very long discussion, and this, I wrote a number of manifestos, which were along the lines of, you make the minimum number of choices day one, because we want to ensure that day two is always there, is always able to be flexible. If you want to turn off a component, if you want to turn on a component, if you want to install a new operator, if you want to install a custom network SDN. And yeah, sure, there'll always be some changes that are just going to be hard, right? Going from one cloud provider to another on an existing cluster gets a little crazy, although Mike will probably ask us to do that at some point in the future. That idea, though, of changing configuration after the fact, we spent a lot of time on this because it simplifies the install experience. It de-risks install, and it makes after-the-fact administration that much easier.
Yeah, so as an example here, a lot of people immediately after they install an OpenShift cluster set up authentication. So we wanted that experience to be really simple. What this is driving is just kube resources in the back end. So while you see me doing it in a UI, which is really nice in a demo, you could just kube control apply this config on your cluster once it's up. And so here I'm just going to say, I've got this horrible message saying, hey, don't log in as root. So I'm configuring a set of users for the auth server. And like anything else, when we go back and see that that config change was made, our authentication operator is picking up that that change has happened and now configuring authentication on the server. And within 20 seconds or so, this will be set up. The other area that was important to us, you've seen a lot about the control plane, was there are some differences around how we manage individual hosts in the fleet. And so out of the box, this cluster that's provisioned, you have the traditional idea of Kubernetes nodes. And so this is an HA setup. If I go and look at one of these nodes, what is a little different here now is you can see that it's running RHEL CoreOS. And so this is the integration from the CoreOS team and our RHEL Atomic team on trying to make sure that OpenShift 4 can run really awesome on an immutable operating system.
Yeah, and the immutability is actually a really key part. So there's always been this tension around systems management, which is computers are big, complex things, and we've gotten used to thinking of them as this big, complex thing that you put a bunch of changes onto and walk away. And a lot of the advantages operationally that people have seen over the last 5 to 10 years have been taking a step back and saying, I want to treat these like a black box. And RHEL CoreOS is actually a culmination of that. It takes the RHEL kernel, takes the RHEL user space. Our upcoming RHEL 8 version is what RHEL CoreOS is based on, so it's RHEL 8 just as much as the version that you would install directly from an ISO. And the idea is that it's programmed and it's built to be driven by the cluster. It's part of the cluster. And we got 30 minutes into this talk without even talking about a host once, and that's how we want everyone in the audience to be able to think about managing machines. Like, managing machines should be easy. The combination of these two, immutability, being driven from the cluster, and being a very simple touch point, is the heart of OpenShift 4.
Yeah. And so there's an optional capability in 4 where you can start to drive into the underlying IaaS layer. So you'll see there's a new resource here called machine. And this lets you find out the actual machine compute element that's backing that node. And so in the beginning of this talk, I was working on an operator. It's going to take a ton of compute. I'm going to need to scale up my cluster really easily. And so I can just very easily add, 5 new nodes. 100. And and then what's going to happen here is that the machine resource, it's very scoped to just describing the computer you want to create in the cloud. It's going to boot with RHEL Core OS. That RHEL Core OS server is going to talk home to an ignition server in our cluster that knows how to configure that piece of compute. And so we have master and worker machine config pools. That machine will join as a worker, and then once that machine boots and gets the software applied, you'll suddenly see we have 8 machines, and this machine config pool will ensure it's kept up to date.
And unfortunately, since infrastructure is still kind of slow, it's going to take 5 or 6 minutes. I mean, that's why everybody uses containers, right?
Yeah.
But this idea, though, of these machines being managed by the cluster, we wanted that to work on bare metal as well, so stay tuned for some exciting announcements this week. We also wanted it to be easy to upgrade any server. And actually, RHEL Core OS actually gives us that nice ability, which is we can do in-place updates very easily. So you don't have to add new machines to take the old ones out of rotation. We can do updates in place. And in both of those cases, whether it's on the cloud, whether it's on in a private data center, or whether it's just a couple of boxes sitting underneath someone's desk, it updates the same way.
So just a quick time check, Diane. Do we have 5 minutes or 1 minute?
We have 5 minutes.
5:42.
We don't want to delay NASA.
We don't want to stop NASA. Come on. So real quickly, Derek, you talked a lot about install operating system automation. You talked about operators and baking in best practices into the software, codifying it. What about the users? What about the people who use the platform? What did we do for them?
Yeah, so Diane talked about Operator Hub in the brief intro. And Operator Hub is now exposed inside the cluster under our catalog. And so as an admin to the cluster, I can expose operators that I want to make available to my users. And so this is the idea of what we like a lot about the cloud is that a resource is just an API away. You want to be able to get that same experience in your environment wherever OpenShift is running. And so earlier when I was working on this operator right here, I was using Che, which is hosted on our online service. And so if you wanted to run that same experience on premise, we actually have an operator for Code Ready somewhere down here.
And there's going to be a lot of talks this week about operators and partners and ISVs who've integrated with Operator Hub. For us, well, not everybody might want to write an operator. We're not taking away any of the flexibility or power of Kubernetes. We think that the operator pattern, however you implement it, is a great way to boil down the complexities of managing and running software into what do you want, saying what you want and then letting the system take care of that for you. That's a key part of how do we get better at operations is we have to stop getting in the details and let the computers do the work for us.
Yeah, so it's hard to look at that wall of icons on a really big display right now. But just as an example, if I wanted to offer Kafka to my users on the cluster, as an admin, I can install this operator. And similar to how the actual cluster itself can be subscribed to an update channel and optionally choose when and how you want to update it, the same thing goes for the end user content operators. And so here, as an admin, I'm just going to be bold and automatically let updates happen and subscribe to this operator. And so as an end user, if I was to log in with a different persona, and I will switch over to my default cluster. And if you imagine that I am working on an application, as an example, in our normal end user developer catalog, you get now a mix of templates as you traditionally had in OpenShift in the past, as well as new operators. And so as that operator I just installed on the cluster became available, you'll see that I now have new options associated with the existing operators my cluster has been allowed to install. So if I want to go and say, my application really needs a Kafka cluster, we don't want our end users to have to know how to write tons and tons of YAML to know how to deploy something on top of Kubernetes. And so with that spirit in mind, I can say, OK, I want a Kafka cluster in my namespace. I will create it. And what we've done is taken then the intelligence of the teams that know how to best administer Kafka in the same way that we feel we can do a decent job at the underlying Kube platform. And a user can just have a Kafka cluster and API call away. And so I will create this.
It's a good thing you scaled up those extra machines.
Yes.
Kafka's a little big.
And so what we'll see here is I now have a Kafka resource in my cluster, just like you could have pods and deployments and daemon sets. And here I have my Kafka cluster. And without needing to have a PhD in Kubernetes, I can see that the operator is creating a ton of services, stateful sets, and pods and secrets to manage that. And once this rolls out, the operator is going to ensure that this thing is always running. This thing gets upgraded according to my admin policy. And just as an application developer, I can consume the technology without needing to know all of the back-end detail.
Cool. Awesome. So with that, I think we're out of time. The 4.0 platform, you gentlemen made some really bold design choices. And I haven't seen that sort of courage since the 3.0 release went out. This community built some amazing things off of 3.0, and we're all looking forward to what you're going to build off of the 4.0. Thanks, everybody.
Thank you.